Hey everyone, how are you doing? Welcome back to another weekly coding hour of GDSC City University of Seattle. For this week, I'm gonna walk you guys through what we have learned last week quickly, and also let's solve the question from last week. So last week we have looked at BigO notation, right? And here's a quick summary. Basically, BigO is there to help us evaluate the performance of your program, and it consists of two factors: the time it takes for your program to complete or to run, and the space that your program is going to cost the computer. And in this picture, we have time is on this side, and then space is on this side. And the best big O we want to have is always O of 1, O of log n, or O of n. It's always the acceptable ones. Anything above that could cause your program to be much lower. So anything in the red zone, if your program is in the red zone, you might want to try to reduce the time and space complexity as much as possible. So again, O of 1, O of log n, O of n is always the ideal solutions that we're trying to go for. So right, with that, hash table is also another concept we looked at, right? It's always helpful in many situations for us to help reduce the time and space complexity of our program. And basically, long story short, a hash table is a data structure that can store keys and values, and it has constant lookup time. So with that, it will help save a lot of time for us if we need to go find any key pair values. Right, so that's what we have looked at last week, and also this is the problem we bring up from last week, but we haven't get a chance to solve them. And this is a Leetcode problem number 771. It's called Jewels and Stone. So basically what this question is asking is, if you're given a string called jewels, which is representing the types of stones that are jewels, and then there's another string called stones, and that represent the stones you have. And each character in the stones string is a type of stone you have, yeah? And you want to know how many of the stones you have are also jewels. So long story short, for each character in the stone, if it's the same as each character in the jewels, then it is considered a jewel. And letters are case sensitive, so that means if you have a lower a, it is not considered the same as a capital A. So to make it more clear, let's look at example 1. In jewels, we have a small a and a big capital A, right? And in stones, we have small a, 2 capital A, and then 4 small b's. And so looking at each, so we need to consider each character of the string in jewels, right? So for the first character is a small a, and now I'm gonna go look in stones to see if there's any small a's, and there's 1. So then right now we have 1. And then for the second character in jewels string, which is the big A, I'm going to look in stones again to see if there's any big A's, and we have 2, yeah? So right now in total we have 3, and then that's it for the jewels. So then that's why the output we are expecting here is 3. And then for the second example, we have only small z for the jewel, and for stones, there are only big z's, there are no small z's. So with that, we are returning 0 as the input, right? So let's look at some of the solutions we can tackle this problem. And there are several ways we can go about this problem. Let's open Leetcode and let's work on it together. So the first problem, the first solution, if you cannot think of any solution, just always try to brute force, which is always a great start, right? And so here's our problem again on the left-hand side. And if you're new to Leetcoding, you can ignore the constraints for a little bit. and then you can go back to it later. It's always very helpful to pay attention to the constraint for sure. However, if you are new to programming, you don't want to have too much information at once to confuse yourself. All right, so the first solution, so look on the right hand side, right? Here's where we are writing our code, and you can choose whichever language you are comfortable with, and I'm going with Python 3. So for the first approach, let's try to brute force this problem, right? So what I'm going to do for the approach 1 is just compare every single character we have in joules with every characters we have in stones, and to see if we have any matching answer. So for example, this one, right, the way I explained to you is I have A in joules, and I'm going to look for every character in stones to see if there's any A. And then I look for the capital A in joules, and then I will go look for every single character in stones to see if there's any matching characters. So let's see how we can do that. So how I can do this approach is probably I have to go through each character in joules, right? So that's probably gonna cost me a for loop. So let's say I have for I, which stands for each character in joules. And also while I'm looking for at each character in joules, I'm gonna have to look for each character in stones, right? So at the same time, I'm going to have another for loop to check for every characters in stones. What I'm going to do is, let's say if there is a matching character, right? Then I'm just gonna add it to our count. So in the end, we want to return how many joules we have, right? So we want to return the total number. So with that, I'm going to have a count variable. I'm going to set it to 0 in the beginning. And then let's say if I is equals to j, that means if the character in joules equals to the character in stones, I'm going to plus 1 to the count, and then in the end I'm going to return count. All right. So let's say if there's any character, it should keep adding up, and then it should return count, otherwise it's going to return 0. So let's run the code to see if it works. All right, so it seems like it's working. And let me submit this code and to see if we pass all the test cases. Okay, so it is succeeded, and it seems like our solution worked. Now let's look at the BigO notation of our problem. So as you can see here, there is a for loop, right? So, and this for loop is going to run as many times as the amount of characters I have, or the size of my string, right? So it's going to be O of n, and n is the size of my string. So that's one for loop, and then right inside this for loop, we have another for loop that's going to iterate over each character in a stone, and the size will keep increasing as the size of my string increases as well, that's for sure. And then for this count, it doesn't cost us so much in general, so we don't want to care about it for now. So since we have two O of n's inside each other, it's going to be O of n's times O of n, and that gives us O of n squared. And now going back to our BigO notation, right? So O of n squared is in this red zone. That's not very ideal for this program. It is a small program. However, if we have a big program, that's going to be a little bit slow. So let's see if there's any way we can improve our problem, right? So with that we can have a look at this second approach, where we're going to use the hash map, which you guys have learned in the last week. So here's our hash map again. What it does is it's going to look like a table, and it's going to store a key value pair or key value pairs, right? So applying that to this question, what I'm going to do is I'm going to create a hash map for the stone string. Yeah. So for this hash map, I want to store the amount of time that a character show up in stones. So by that, what I mean is I'm going to have a table that looks like this. So there's going to be indices, and then there's going to be, what I'm going to do is I'm going to have the frequency. Yeah. I'm going to store the frequency and how many times a character show up. So then, and then there's the character. So let's say for character A, now actually let me put it this way. The character and its frequency. So character is going to be the key, and frequency is going to be the value. So for character small a, so right now we're looking at stones, right? Frequency show up is going to be 1. And for character big A, frequency shows up is going to be 2. And for character small b, frequency shows up is going to be 4. And so that's going to be our hash map. And after I have this hash map, what I can do is I can use each character in jewels to see if it exists in our hash map. And then if it does, I'm just gonna get the frequency of that character. And then in the end, I'm just gonna combine all the frequencies together. And that should give me the amount of jewels I have. So let's try to do that. So in Python, there is a library called collections, and that helps you to create a hash map with the frequency and the value all together. It might be different in other languages, but so I'm going to create, so I'm gonna have a count variable, and I'm going to store all the collections dot counter of the stones. So what that means is this library is going to go through the stones, count how many times each character shows up, create a hash map, and then store it in this count. Right. So what I'll do is, let's say I'm going through, so we are done with the map, right? So right now we're gonna check each character in the jewels to see how many times show up. So what I'll do is for each character in the jewels, I'm going to create another variable. I'm going to create the answer. For now, I'm going to set it to 0. And then for each character in the jewels, the answer is going to be itself plus the amount of time that a character show up. And so what I mean here is that for every character in Jewel, so for example, it's going to look this way. So each time, for let's say, look at A. So I'm using A to look inside our map, right? Let's bring up our map. All right, so this is our map again. And what it does is basically, I'm using A, jewels, and then for jewels we have A and A. So I'm going to put it here. So we are looking at this example, right? So for each character in jewels, which is starting with this small a, if A, please get me the frequency of A. So that's going to give us 1, and then 1 plus 2 ants. So for now, our answer is going to be 1. And then next time when we iterate, and it's going to look at the big A in jewels, right? And then we use this A as the key to look up its value in this count collection, which is this table. And we having big A, right? So it's going to return us frequency of 2. And our answer previously was 1 plus 2. That gives us 3. So once we have checked all the characters, we going to return count, return the answer. right? And let's comment all of these out and run our code again to see if it works. Okay, so it seems like it's still working, and let's submit to see if we pass all the cases, all the test cases. All right, so it seems like it's still working. Let's not forgetting our time-space complexity. For the first solution, the time complexity causes of n squared. However, for the space complexity, since we're not creating any extra data structure, is going to be of 1. Right, so now let's compare to the second problem, where you see that we have cut down one for loop already. And so now we only have this of n, which is one for loop, that we still have to iterate through each character in this joules, right? So that still causes of n if joules, the size of joules keep increasing, our time that we have to spend to iterate through is going to keep increasing. So, and then with that, for this one, the collection is going to cost us in terms of space. Is going to cost us of n, because if we have more items we want to keep adding to our table, our hash map is going to keep increasing, right? So that is the space. How about the time? So hash table give us a constant time lookup, delete lookup and adding. So that is going to cost us of 1 only, which is really, really good. So in general, for this question, for the space, we are looking at, we'll only care about the one that costs more, right? So space, we have O of n and O1, so we're just looking at O1. And then for the time complexity, we are actually looking at, for the collection, we are looking at O of 1, right? However, for this for loop, we are looking at O of n. So then, in the end, again, we only care about the one that causes more. So we're looking at O of n. So then, for this second solution, we're having O of n and O of n. However, if you can see, for this first solution, we are having O of n squared, but second solution, we have reduced it to O of n. So if we look back in our BigO notation, we go from O of n squared to O of n. So that is definitely an improvement. So yeah, so that is the solutions for this question, and please share with us your solution if you have a different one, or if you are using the same solution, still share with us and let's discuss together. Happy coding! Bye! See you next week in another episode of CDU Google Developer Student Club Weekly Coding Hour. Bye!